Okay, now that we've finished our logistics, let's dive into our first actual computer science topic. We're going to start off by talking about the difference between hardware and software. So when people talk about hardware, they're talking about physical devices that they can hold or touch with their hands. So really, it's anything physical. A laptop is a piece of hardware, a monitor, a keyboard, a printer. Your phone is hardware. Um, on the other hand, software is the intangible part. It's the code or programs that are running on the hardware. And this is what you usually interact with every day. You use Microsoft Word, maybe. You might use Chrome for your web browser on your computer. On your phone, you might have the Instagram app installed, which is also a piece of software. There's also different layers of software, and you'll talk about this much more later on in the curriculum, beyond this course in further courses. But for example, on your phone, if you have an iPhone, Instagram is an app, but that app is running on an operating system called iOS. And so iOS is a whole set of software that's running on the hardware, the actual Apple device, the actual iPhone that Apple produced. And so Instagram is software that's running on the operating system, which is software which is running on the physical device that Apple made and sold you in the store. This distinction is important because it'll help us kind of divide and separate out the side that is the actual computer itself, the hardware, the processor that's inside of your computer that actually does all the thinking and what it understands, from the software, which is what we in this class are going to be learning to write. So in this class, we're going to be focused almost entirely on the left side here. In fact, you'll notice this is kind of exciting. These are the first couple of lines of Python that you're seeing, which is the language, one of many languages, but the language that we're going to be using to program and write very basic software. And if you're curious, well, this side on the left, it may not make sense to you yet, but it will certainly in the next few weeks. But this is the closest thing to human language that we can use to communicate with computers. And then there's something called a compiler, which translates from this human readable form to this binary code, which is what computers actually understand and can actually run. But even though for most of the course we're going to focus on the stuff on the left, today we're going to focus on binary code and kind of the area in the middle, because understanding the language that the computer speaks will help us write better software and be better at Python and understanding what Python is actually doing. So, digging into binary. Binary is the language that a computer understands, and in the same way that humans understand letters, like A, B, and C, computers understand ones and zeros. And each of these ones or zeros is called a bit. So you can see here this string of ones and zeros is a string of bits. So 1100, 1001, 1101, and so on and so forth. And this is an example of something that very well you could give to a computer, and it could try to do something with those bits. Now, each set of 8 bits makes up 1 byte. So a byte is a set of 8 bits. And each byte can actually be decoded into a human readable number. So you'll notice, because each of these can only be a 0 or a 1, we call this a base 2 numeric system. Whereas what we're used to is base 10, because you can go, each digit that we have can go from anywhere from 0 up through 9. So it can have 10 possible values. So we're going to figure out how to decode these bytes into human readable numbers, so base 10 numbers. But first, let's have a reminder of how human numbers actually work. So human numbers are base 10. They work by adding up multiples of powers of 10. That's why we call it base 10 system. So we always start on the right. The rightmost digit here is a 7. It's the 0th digit because it corresponds to 10 to the power of 0, which is equal to 1, right? It's the ones place. The next digit over is an 8 here. It's 10 to the power of 1. So the tens place. Then the next digit over is a 3 here, which corresponds to 10 to the power of 2, so the hundredths place. And finally, the last digit in this number, or the first if you're reading from left to right, corresponds to 10 to the third, which is the thousandth place. And so if I color code these, we can see that the way that we get the total value of this number is by multiplying each digit by the value of the place that it is in. So 4 is in the thousandths place, so it's 4 times 10 to the third, plus 3 times 10 to the second power, plus 8 times 10 to the first, plus 7 times 10 to the 0th power, which is just 1. And so we see 4,308 tens, or 87. And that's exactly what this number is equal to. We get back to the number that we started from because we are breaking down. This is exactly how you build up our number system, base 10.